Ever wondered what would happen if a massive solar flare hit Earth? Picture this. The sun, our closest star, a swirling ball of hot, glowing gases, occasionally belches out colossal bursts of radiation known as solar flares. These flares are not just beautiful light displays, they're pure, unbridled power, the kind that can impact an entire planet. Solar flares are classified into three categories: A, B, C, M, and X, with each letter representing a tenfold increase in energy output. A-class flares are the smallest with the least energy, while X-class flares are the most powerful, packing enough energy to power the entire United States for 1.5 million years. Yes, you heard that right, 1.5 million years. But what causes these flares? They occur when magnetic energy that is built up in the solar atmosphere is suddenly released. Think of it as the sun releasing pent-up frustration in a fiery tantrum. This explosion emits radiation across virtually the entire electromagnetic spectrum, from radio waves at the long wavelength end to X-rays and gamma rays at the short wavelength end. Now, these solar flares, especially the X-class, can have significant impacts on Earth. They can disrupt radio communications, GPS systems, and even cause power outages. Astronauts in space, stripped of the Earth's protective atmosphere, can be exposed to dangerous levels of radiation. Even our planet's magnetic field takes a hit, resulting in spectacular auroras which, while beautiful, are a stark reminder of the power the sun wields. Solar flares, in their essence, are a testament to the sun's might, a force that, while usually a distant, benign presence, can assert its dominance in a flare of blinding light and energy. The sun, while our life-giving star, is also a celestial titan with a temper, capable of releasing bursts of energy that dwarf anything we humans can produce. Now, imagine the most powerful category of solar flares, the X-class, heading towards our planet. Don't worry, this isn't a doomsday prediction, but a setup for our next discussion. Stay tuned. August 19, 2004, a day marked by an extraordinary solar event. On this day, a powerful X-class solar flare erupted from a sunspot known as AR 2887. For those unfamiliar with the term, a solar flare is a sudden flash of increased brightness on the sun, usually observed near its surface and in close proximity to a sunspot group. They release vast amounts of energy, equivalent to millions of hydrogen bombs exploding at the same time. Diving deeper into the characteristics of this particular flare, it's important to note that it wasn't a fleeting event. The flare lasted over 30 minutes, a substantial duration in the grand scheme of solar activity. Accompanying this flare was a major coronal mass ejection, or CME. CMEs are significant releases of plasma and accompanying magnetic field from the solar corona, often following solar flares. This CME was directed towards Earth, a phenomenon that can have significant implications for our planet. Now, let's discuss the immediate effects of this solar flare. The flare's powerful eruption caused disruptions in radio communications and GPS systems, particularly in the Western Hemisphere. Imagine a day without GPS, without the ability to navigate our world with the ease we're accustomed to. That's exactly what occurred on that day in 2004. South America, in particular, experienced the brunt of these disruptions. Such solar flares can also impact satellites and astronauts in space, making them a significant concern for space agencies worldwide. The frequency and intensity of solar flares follow an 11-year cycle. During this cycle, the sun goes through periods of high and low activity, known as solar maximum and solar minimum, respectively. But let's not get ahead of ourselves, and all these effects occurred while the flare was still on its way to Earth. The real show was yet to begin. The flare's journey towards Earth and the ensuing effects form an intriguing tale, one that we'll delve into in the next scene. So, what happens when such a powerful solar flare collides with Earth's magnetic field, you may ask? Well, the answer lies in a fascinating phenomenon called a geomagnetic storm. When a coronal mass ejection, or CME, from a solar flare hits our planet's magnetic field, it can cause a storm of epic proportions on a cosmic scale. This storm isn't one that brings rain or snow, but rather a spectacular light show in the sky. Imagine the night sky lit up with colors, swirling and dancing as if the cosmos itself is putting on a performance. These are the auroras, also known as the northern and southern lights. A powerful solar flare can supercharge these auroras, making them visible in places they're usually not seen. It's a visual spectacle that has captured the imagination of humans for centuries. But while the auroras are breathtaking, the impact of a solar flare on Earth isn't all beauty and light. There's a darker side to this cosmic event. The same geomagnetic storm that powers the auroras can also wreak havoc on our modern technology. Communication systems, particularly radio communications, can be disrupted when a solar flare strikes. This is due to the storm's effect on Earth's ionosphere, an atmospheric layer that plays a key role in transmitting radio waves. And it doesn't stop there. More serious still is the potential for power grid failures. The electromagnetic energy from a solar flare can overload power grids, leading to blackouts. Imagine a world without electricity, even for a short time. No lights, no internet, no refrigeration. It's a chilling thought, isn't it? Moreover, these solar flares can harm satellites orbiting Earth. These satellites are essential for everything from weather forecasting to GPS navigation. A powerful enough solar flare can damage these satellites, leading to disruptions in these vital services. The effects of a single solar flare can be far-reaching, altering our daily lives in unexpected ways. As we marvel at the beauty of the auroras, let's also remember the power of the sun and its potential impact on our planet. It's a reminder of our place in the cosmos and the delicate balance that exists between our technological world and the natural forces of the universe. But this is not the first time Earth has faced such an event. Let's take a step back to the year 1859 to an event known as the Carrington Event. This was a time when the world got a first-hand experience of the potential devastation from massive solar events. The Carrington Event was a powerful geomagnetic storm triggered by a solar flare, a blast of radiation hurled directly towards our planet. This event was pivotal in revealing the intimate connection between solar activity and Earth's magnetic field. It was a stark reminder of our planet's vulnerability to the whims of our star, the Sun. This event was so significant that it caused telegraph systems across Europe and North America to fail, some even shocking telegraph operators. Telegraph pylons threw sparks, and paper around the machines spontaneously caught fire. The event was so powerful that auroras, usually restricted to regions near the poles, were seen as far south as the Caribbean. Fast forward to today, our reliance on technology has grown exponentially. We live in a world where our lives are intertwined with technology, from our communication systems to our power grids, from our transportation networks to our international space stations. The potential risks to modern technology from such solar events are immense. A solar flare similar in magnitude to the Carrington Event could cause widespread power outages, disrupt communication networks, and even damage satellites. The economic implications of such an event are staggering, running into billions, if not trillions of dollars. But why does this matter? Why should we care about an event that happened over a century and a half ago? The answer lies in preparedness. By understanding these historical events, we can better prepare for similar occurrences in the future. We can develop strategies to mitigate the impact, create technology to shield our existing infrastructure, and devise response plans to ensure minimal disruption to our lives. Remember, the Sun is a dynamic and unpredictable star, and as we've seen, it's capable of hurling powerful solar flares directly at us. Understanding these phenomena is crucial for our preparedness against future solar events. So, where does this leave us in terms of future solar events? Well, solar flares, as we know, follow a roughly 11-year cycle of activity. This means that the frequency and intensity of these cosmic fireworks wax and wane over a period of about a decade. Currently, we're in the upswing of a cycle, which means that the potential for future X-class flares is very real. Scientists all over the globe keep a vigilant eye on our star, monitoring its activity for any signs of potential flares. Satellites and ground-based observatories work round the clock, capturing data and images of the Sun in multiple wavelengths. This information doesn't just help us predict when a flare might occur, but also gives us crucial insights into the complex processes at work on the Sun's surface. As part of our ongoing efforts to understand and predict solar events, we're constantly refining our models and theories. We're improving our forecasting abilities, developing early warning systems, and formulating strategies to mitigate the impacts of these space weather events. But why is all this research and preparedness so important? Well, our modern society relies heavily on technology, from communication systems to power grids to navigation satellites. A major solar event, like an X-class flare, could disrupt these systems and cause significant damage. By understanding these solar events and preparing for them, we can protect our infrastructure and ensure the continuity of our daily lives. Ongoing research into solar activity isn't just about disaster prevention, though. It's also about exploration and understanding. The sun is our closest star, a powerhouse of energy and the source of all life on Earth. By studying it, we deepen our understanding of the universe and our place within it. As we continue to unravel the mysteries of the sun, we are better equipped to face the challenges posed by its immense power. And with that, we don't just ensure our survival, but we open up new frontiers of knowledge and discovery.